Okay, so let's get started. We're going to be doing Nix today, at least for this portion, and we have been going through the nix.dev site. There is a whole series of videos on YouTube, so you can look in the description, go to my whatever bio link or something, go to YouTube, and then you can see like we basically went from first steps, language basics, packaging, all of this stuff. Language basics probably took the longest time because um, let's see here. Oh, it doesn't like break it out, but like there were lots of subsections here. And now we're up to cross compilation. So I guess what we're doing right now is learning how to compile packages so we can add it to the Nix packages system. I think a lot of people who use Nix don't really play with this part of it, but it's interesting that if you run into software that isn't in Nix, that is pretty easy for you to get it working and compiling, and then you can, add it to Nix and grow the library of Nix packages that is available. So let's do cross compilation. Let's see here. I think we're set up to do stuff, right? Let me know if the chat text gets in the way for you reading this stuff. So cross compilation. Nix Packages offers powerful tools to cross-compile software for various systems. What do you need? Experience using C compilers. It's been a long time since I was working on C. So yeah, but yeah, run C compilers and there's linking. Basic knowledge of the Nix language, we got that. Platforms. When compiling code, we can distinguish between the build platform, where the executable is built, and the host platform, where the compiled executable runs. What is this one for? Whoa. Terminology for cross-compilation platforms differs between build systems. We have chosen to follow autoconf terminology. Okay, that's just like some academic sort of. Native compilation is the special case where the two platforms are the same. Cross compilation is the general case where those two platforms are not. Right, because since there's multiple platforms, like we saw with these packages, Arch 64 Darwin, Linux, 686 Linux, 686 64 Darwin, Linux, so all these platforms that like probably you're only going to be one of them and there's all these other platforms, I guess was what they're saying. So in general, you're going to do it once, natively compiling, but cross-compiling is what happens most of the time. Cross-compilation is needed when the host platform has limited resources such as CPU or when it's not easily accessible for development. The Nix Packages package collection has world-class support for cross-compilation after many years of hard work by the Nix community. All right, now I'm getting kind of excited to learn how does this all work. Are we going to cross-compile locally, or I'm guessing? What's a target platform? This is a third concept for a platform we call a target platform. Where did they say target platform already? There's the host platform, native compilation, cross compilation, and target platform. Okay, these are all the concepts that we've learned so far. The target platform is relevant to cases where you want to build a compiler binary. In such cases, you would build a compiler on the build platform, run it to compile code on the host platform, and then run the final executable on the target platform. Isn't the build and the host platform the same? So the build platform is where it's built, and the host is where the compiled executable runs. I see. The target platform, in such case, you would build a compiler on the build platform, run it to compile code on the host platform. Okay, so this is where you're going to be running it, and run the final executable on the target platform. Okay. Since this is rarely needed, we will assume that the target is identical to the host. That's sure, they could have said this earlier on because, yeah, like you would think the target is the same as the host, right? Because the host platform was where you're going to run the executable. That was the definition of it. So that's kind of your target, right? When would it not be your target? Determining the host platform config. The build platform is determined automatically by Nix during the configure phase. The host platform is best determined by running this command on the host platform. Whoa. So Nix build, Nix packages. So this is taking the Nix packages. This is the version number that we're giving it. And we're building GNU config. I think. Let's see what happens when I try running this. Well, I feel like they lied to me because that did not work. In the case this is not possible, for example, when the host platform is not easily accessible for development, the platform config has to be constructed manually via the following template. Findus says, if you work on an x86-64 platform but you want your program to run on ARM, could be a case. Ah, okay. But the host platform would then be the ARM, right? Because that's where the executable is going to run. And that's your target. Also, the host and target are the same. But the build platform is going to be your local machine. That's how I would take that definition. You have your build platform where it's going to be built, that's yours. The host platform where it's going to run, that would be the ARM machine. And the target is where you're going to build the compiler binary. And you would think the target's going to be the same as the host. But I don't know. Maybe like it's not always the case, because you can probably do like maybe you can build it on a different machine architecture. So this didn't work. This was very unfortunate. Command not found. Guess. GNU config. So is GNU config a package? Here's GNU config, right? Does that mean I can install it? What does it give you? It provides no programs. Config.guess. So is this a real path that has something in it? Config.guess. Oh, I'm being stupid. So they say copy this, but this is the response. Guys, like, right? Was this just me? This is not clear. They want you to just run this. You see that would tell you something. This was confusing. Maybe I'm just stupid because you have this copy button and it's going to copy the whole thing, right? Oh no, it doesn't. Oh my god. I'm feeling really, really, really inadequate. It's like building the Atari assembler to run on your computer that assembles will build a program to run on Atari. Yeah, I guess so. The advantage is that you only need to work slash compile on your normal platform, then transfer your program to maybe Pi or Mac M1 platform. Yeah, I still don't get the terminology because in that case, the host where you're going to run the executable is the Pi or Mac M1, and the target is also the Pi or Mac M1, but your host could be like, Linux or whatever. So when is we will assume target is identical to host. I would think that most of the time it is, or almost all the time. Anyway, it doesn't matter. In this case, it is not possible, for example, when the host platform is not easily accessible, the platform config has to be constructed manually via the following template. CPU, so this is our CPU, x86-64, vendor, PC, OS, Linux, ABI. So let's see. Um, Note that vendor is often unknown. So like PC in mine would often be unknown. And ABI is optional. There's no unique identifier for a platform. For example, unknown and PC are interchangeable, which is why the script is called config.guess. If you can't install Nix, find a way to run config.guess. Usually comes with the autoconfig package from the OS you're able to run on the host platform. Some other common examples of platform configs, and here is, so I guess this is the vendor, Apple PC W64 Apple, right? And here's the CPU, Arch64, Arch64, x86 64, and Arch64. Is Arch64 like ARM? I don't know what Arch64 is. Yeah, it's ARM. Makes sense. Note, macOS Darwin is a special case as not the whole OS is open source. It's only possible to cross-compile it between Arch64 Darwin and x86-64 Darwin. Arch64 Darwin support was recently added, so cross-compilation is barely tested. Alright, got it. I've heard a lot about Darwin, but I don't know what it is. Yeah, that's not good. Darwin is a Unix-like operating system of Mac OS. Oh, so it's just the Mac operating system. Is that it? Got it, got it. All right, so all it means is it's the Mac OS. Got it. No wonder it sounds so familiar. Choosing the host platform with Nix. Nix packages comes with a set of predefined host platforms for cross-compilation called packages cross. It's possible to explore them in Nix REPL. Let's see what version we have. 218. So we don't need that, but we will add it. Nix packages. So here we go. This is very useful. Maybe I'll put it in the cheat sheet as to like how to start REPL. Yeah. Oh, this is it right here. We just did it. I already wrote it once. There, we may just make an example. There we go. That's good enough. Welcome to Nix. Packages cross tab. So we do packages cross dot tab, and now we have all of these things. So we can see all the different things that we can kind of like cross compile to, I'm guessing. iPhone 32, iPhone 64, that's crazy. These attribute names for cross-compilation packages have been chosen somewhat freely over the course of time. They usually do not match the corresponding platform config string. You can retrieve the platform string from packages cross.platform.standard.environment.hostplatform.config. So let's look at iPhone 32 because that's like, what is that? Then we do standard environment dot host platform dot config, and it is this, the CPU is ARM, the vendor is Apple, and I guess iOS is the OS. Is that how it parses? Yeah, OS, and there's no ABI. I actually have no idea what an ABI is. That doesn't sound right. Application binary interface. All right. So is this, are we talking like ELF or something like that? What are we talking about here? Allows a program from one operating system supporting that ABI to run without modifications on any other such system. All right. So it's something about platform compatibility or cross-platform stuff. Okay. So where do we get to? We got here, we got the config. They gave us an example here of what this one might be, and it's Arch unknown Linux GNU. Let's see if we get the same thing. Arch 64 unknown Linux GNU. Yep. If the platform you seek hasn't been defined yet, please contribute it upstream. Oh wow, you can add new platforms. Specifying the host platform. How are you guys here? You're holding up? Are we learning anything? I don't know if we're learning anything yet. Specifying the host platform. The mechanism for setting up cross-compilation works as follows. Why is like coffee making me burp? And coffee should not be making me burp. It should just wake me up, right? All right, take the build platform configuration and apply it to the current package set called packages by convention. Got it. The build platform is implied in packages import Nix packages, curly braces, to be the current system. This produces a build environment packages.standardenv with all dependencies present to compile on the build platform. Okay, we've done this before when we just like build anything, right? Like we built the iCAD or something else previously in videos. So standard environment is basically everything we need in our current, I guess that would mean native build system, right? The local one. Apply the appropriate host platform configuration to all the packages in packages cross, taking packages cross host hello will produce the package hello compiled on the build platform to run on the host platform. Oh boy. There are multiple equivalent ways to access packages targeted to the host platform. Explicitly pick the host platform package from within the build platform environment. So here we have our normal Nix packages, right? And then we do packages cross, the platform name and the package name, hello. So if we do this, we'll just get back what? Like, what is this going to get us? It's the function that's going to help us build this package. All right, got it. So this will be a function that will let us build it. Pass the host platform to cross system. Look at this. When importing Nix packages, this configures Nix packages such that all its packages are built for this host platform. So Nix packages cross system equals, and then we pass it this information. Usually in Nix packages we were passing nothing, and here, and I think in the past we've passed like overlays and config. So here we're passing cross config, and it is an attribute set that has the config name value pair. And then when you get back packages, it's basically as if you type this, packages.cross-packages. It's as if you typed all of this, because the Arch stuff that's here is in here. Oh, maybe the issue, I just thought of what maybe the YouTube issue is. Well, let me try something. Sorry, just hang in there for a minute. Yeah, maybe that'll work. We'll see. We'll see what happens. Because I think someone has to type something before it wakes up. All right, let's see what happens. Okay. So this is what we just looked at. Equivalently, you can pass the host platform as an argument to Nix build. So here we're passing it as an argument to Nix build. Got it. Minus a hello. So if we do this, this should actually build it, right? Oh, crap. I didn't mean to do that. This should actually build it, right? Yeah, I think that actually builds it. And then in here, bin hello. And notice like we get an error because it's not in our, it says exec format error because we are not running Arch unknown Linux GNU, but we are running, what was that guess thing that we did? We're running x86. So let's see. We do nix packages, build, but that's not what we put in here, right? We need something that's equivalent to PC Linux x86 Arch iPhone MPS. Which one would we be? I'm not actually sure which one we would be. Maybe I can just take this thing here and put it in there. Let's try. Here's the build. And then we're going to pass in our config x86 64 PC Linux GNU. Looks like it was happy with that. And now it's like building or unpacking or something, don't know. Wow, it's getting a lot of stuff here for building this. Maybe because it's like building cross-platform. You guys can now see how slow my machine is. It's getting GCC. It's still checking. I'm not sure what it's checking. All right. Well, let's keep, while it's doing that, we can keep looking. We can kind of like move ahead, right? So you can pass the host platform as a build as an argument. This is what we just did. Cross-compiling for the first time. To cross-compile a package like hello, pick the platform attribute. Arch64 multi-platform in our case. That was up here, right? This one. And run, and then here we go. This is pretty much what we're doing now. Like this is what's running now, right? Except we're not doing Arch64, which we put in our own platform, but we previously built something in Arch. I wonder why my computer's so slow. There we go. Look at that. Look how happy it's running everything now. I think. No error, please, no error. I don't want to be stuck. It's kind of like driving fast on a highway. You ever get like stuck driving and then like you just want to move fast? It's nice to see it moving fast. Sometimes it's nicer to go the long way and just move quickly while you're driving than like going the faster way technically, but like being stuck for so long. We're just building. Hello, what's going on? Is it like building the whole like compiler system? Holy cow. I think it's building like the whole compiler, cross compiler or something. So, but it's kind of ironic because we're building for our local system. It's kind of fascinating. All right, so let's see here. The hash of the package in the store path changes with updates to the channel. All right, that makes sense because the channel might change other stuff in it. Search for a package attribute name to find the one you're interested in building. Do you mean like just search, right? Yeah, that's what they meant. Do you guys feel like building something in particular? Oh, look at this. What? Windows platform? Oh, so is it going to let me compile for like Windows? That's really cool. Wonder how that. Let's try this out. I'm going to take a quick break though. While this is running, I'm going to use the bathroom. So please excuse me. I'll be right back. It's still going. It's still busy. Why is it still running? Should we kill it? Well, let's start here. Let's look here. While it's doing this, we can probably still use an editor. Real-world cross-compiling of a Hello World example. To show off the power of cross-compilation in Nix, let's build our own Hello World program by cross-compiling it as static executables to ARM something and x86, 64, Windows 64, Ming32 with an emulator. What does this mean? Thanks Thanks for linking me the definition of an emulator. But what is Ming32? I've heard this before. Ah, it's minimal GNU for Windows, free open source environment to create Microsoft Windows applications. So it's kind of like Mono, but like for Windows, it lets you create Windows executables without having Windows, I guess. Learning so much about this stuff. I'm not like a hardware person or whatever, so once we start getting down to this level, like I'm pretty lost. Hey, it's Satoru. Hello, how are you? I've somehow lost YouTube chat again, so sorry I don't have you on there. Isn't GNU POSIX like API on Windows? I guess so. Um, yeah, I guess that's what it looks like, right? Ming doesn't does not rely on third-party C runtime DLLs because the runtime are not it is not necessary. Okay. So I've never used it, but I guess it makes sense that Nix would have something. So let's take a look at this file here. Here it's getting Nix packages from some specific release. Oh god, I can't like actually scroll. Oh, here, I can scroll left and right, but you see it's kind of sucky this way. So what we'll do is we'll kind of just like copy this whole thing, put it in Helix so that we can see it better. I've lost it. Here we go again. We try once more. There we go. And we have cross-compile.nix. Okay, so we'll look at it from here. We are, yeah, I think you guys see my screen. Yeah, I mean, like, why would you really need to use something like that on Windows? It's so much better if you just get on Linux. And now that you have Windows subsystem for Linux, you know, but I guess if you really need to make a Windows application, it's not the worst way to go. So, oh, let me try one last thing. Nope, still not working. I think this was a mistake starting this build. All right, so we're grabbing some specific pinned release of Nix, and then we are import will actually evaluate that here when we pass it this empty attribute set. So this will return us all the packages under Nix packages. Hello world, we find a write text thing under packages. And I don't know what write text takes. I wonder if that's in Noogle. Maybe not. Let's see. Packages write text. It doesn't tell us what it actually does, but it's a function. I probably have to look in the Nix resources, Nix reference manual. Oh, come on. That's where we just looked. Where's the actual reference manual where I have write text? I guess we can just look up here. Or maybe it's part of just Nix packages here. Write text. Nope. How to write a file into, it just say write text. Here's the file name and there's the code. Okay, that's super easy. So all this is saying is it's going to take this text that is in this, the double single quotes here, basically start a multi-line string. So it's going to take this text and write it into this hello.c program. So it's basically a way to say, like, concatenate or echo this stuff into a file is what that part means. So there we go. I could have also read the comment, and that would have probably been helpful. Next thing, a function that takes host platform packages. So cross-compiler for host packages. So this is a function, cross-compiler for. It takes one parameter called host packages. And then it's going to assume that host packages has it's an attribute set that has something called run command cc, and I assume that is running the C compiler. Hello world cross test. Empty attribute string, empty attribute set, and this thing. I guess these are our environment variables. Oh, here's how we run it. cc hello world -o hello. And where's hello world set? Hello world is this thing. I see, so it's this file. So probably after write text actually writes it, it returns the file reference. And then we can compile it here. We can put it, this is an interpolated string. We output it. Ah, look at this. Run the compiled program using the user mode emulation. Build packages is passed so that emulation is built for the build platform. Host packages standard environment, host platform emulator. So this is the emulator for the host platform. Host packages dot build packages. I see. So host packages has the build packages reference, which is where we are. We are on the build platform. So that emulator takes in that. All right. Very interesting. So let's go back to the documentation. If we build this example and print both resulting derivations, we should see hello world for each. All right, I'm going to stop this because this is taking a really, really long time. And where were we? Did I put this cross? Where am I? I'm in prologue. I guess that's okay. Let's not worry. Let's not think too much about this, right? So if we want to build this now, what will this do? Nix build cross platform dot nix. I know it says cat. So what? This is going to return us the actual, this should probably return us the build directories for them, so it doesn't hurt to run this once. The next time it doesn't have to build again. Satoru, how's your day? How's everyone doing? It's cold here in France. Not too cold. It's been worse, and luckily it hasn't been raining. So that's pretty cool. I feel like there's a lot more here that they didn't really go really deep on, but it seems really neat. Alright, so here we are. It looks like it's grabbing stuff so that I can build. This might be that 20-minute thing because it looks like it's doing the same thing where it actually has to build the build system up, which is like the compiler for Pi and also Windows. Raspberry Pi. How did they get Raspberry Pi? How did they know that's the name? Is it in here? Yeah, there it is. So Raspberry Pi. And the Ming one was here somewhere, right? I'm like, when I go to the supermarket and I have to find something, here it is. Ming 32 and Ming W64. So what are we building for? We are building for Ming W64. I probably shouldn't say Ming because it's like minimal GUI something Windows. Anyway, I was saying like, yeah, if I have to go to a supermarket and there's like find this thing in this like aisle of cans, it's or boxes, it's impossible. I like can't find anything. It just gives me a headache. Findus, also cold and dark here in Denmark. Daylight only 7 hours now. That sucks. Yeah, Denmark's worse than Paris. Um, I've only been to Copenhagen and wherever that really famous museum is. But it's not in Copenhagen. You take like a train. But I really like the vibe of Copenhagen. It's kind of like a little edgy, but cool and laid back at the same time. But things are expensive. Paris is expensive, but Denmark seems even more expensive. It was one of the places I was thinking like if I had to live somewhere else, I would consider Denmark or Netherlands. Probably more Denmark though. Oh wow, this is going to take a while. So if I understand this correctly then, yeah, let's make a new shell so that we can like play around with stuff while it's compiling. Don't mind the prologue. So this emulator thing is interesting here. Let's see if we really understand what's going on here. Packages.write text. Netherlands and Denmark very similar. Yeah, not yes and no, right? Like I feel like you can definitely tell Denmark is like the northern countries, and you can definitely tell like Italy is the southern countries. And Netherlands just kind of just feels like in between. It kind of acts a little bit like the Scandinavian countries a little bit, but it also a little bit warmer. I don't know. It's interesting. Aren't you supposed to be doing sword fighting during compiling phase? What? I don't get the reference, Pico. Pico, what's the reference? Help me. I don't get it. I'm not cool. I don't get the sword fighting. No, my hobbies include singing. Is that it? But not sword fighting. Alright, is this still compiling? Ay, ay, ay. I used to play chess, but I'm really, really bad at it. I want to learn how to sight read music more. That's something I'm going to start spending time on, I think. But yeah, alright, so we know packages.write text. This will write, it'll make a file. So does that mean I can like make a Nix file that will do that? Let me try. Because we have Nix instantiate, we have Nix build, and like it's not clear to me really when you use one or the other. Because we first use Nix build, like we use Nix build like maybe we even use Nix build in packaging existing software. yeah, we use Nix build here. And then there was one package here. So, but we passed in -a hello. So it would basically look at, I guess what Nix build does is it looks at, it runs, because we're not passing the file, it runs default.nix. It gets returned an attribute set, and it's going to run the -a and then this attribute name to build the thing it wants to build. All right, that makes sense. So basically, here, when we say nix build cross compile nix, maybe it runs all of them because we're not passing in the one we want to build. Oh, xkcd. Let's find it. Is that legal for me to do? The number one programmer excuse for legitimately slacking off my code. I've seen this. I've seen this. But when I see this, I just read this and I was like, yeah, I get it. Like, but I don't remember the sword fighting part. Um they have like this is a meme waiting for Chat GPT to respond. That's pretty sad. Um I had a friend who used to work with Ada, like government stuff, and literally it would be like it would take I think it might have been a day or even longer to like compile. So like it's insane. It's like I couldn't have even imagined. And I've worked in a few game companies, and building games can take a long time. It's kind of like, because it's pulling in all the art, everything. I really don't think they need to, but like they often end up, doing that way. So a release is really, really slow to get together. But yeah, I just can't, I just hate working on stuff like that. I like it when you can build something pretty quickly. Um, yeah, Rust feels slow to me because, it's kind of one of the slower compilers, but it's all right. I played Go for 6 months, but went almost insane. Yeah, Go's supposed to have a lot more permutations than chess, so that is not surprising. But I was interested when I went to Japan. I was like, oh, maybe I should learn Go because I can find some people there to play with. But, you know, my partner was not so into the idea of spending our time playing Go, watching me play Go, so that didn't happen. As far as I know, Pico says, Nix instantiate is very low level, not really used in general cases. Interesting. So what's the difference between that and build? Maybe build just calls Nix instantiate? Satoru says, and considering that Ada compiler is way faster than Rust, modern C++, is it really? I mean, it seems like it was really slow. Crazy. But maybe it was just like huge projects, right? Because it was like government stuff. So where are we? We were looking to make sure we understood what was going on here. I wanted to write like a test program to see if I understood how to use this, right? So let us write like test1.nix, and we will have we'll just take our boilerplate here. It doesn't matter. Um, right. And now I just want to know if I can use the write text and just make a file right here. So maybe that's what build does. It's expecting like cross compiler for packages. Da, 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 da. I wonder what it's expecting here. So maybe that's the difference because Nix instantiate will actually just run stuff, right? So I can do packages dot, where is it, write? Packages dot write text. Hello dot text. And I'll pass in something. Here is some text, right? So now we have, oh, we don't need this. So now we have, maybe this will work. Let's see. What did I call it? Test1.nix. I think this is why we use build instead of instantiate. Look at this thing. It's going like on an endless, infinite like loop. From the manual, Nix build is essentially a wrapper around Nix instantiate and Nix store realize. Or maybe the machine is targeted is very slow. Gov usually have quite old hardware. Could be that. Stack Overflow. So it was not happy here. Use standard env tests instead pass-through is a make derivation detail. So we should probably go back to how they want us to do this. And the standard way you do that is you have a new file that like test would actually be like this. It would take in the, what would it need? Packages dot write text. And then I guess I can just call write text. This seems a little bit off to me. But we have to call make. Oh, this won't work because make derivation. Yeah. I have no idea how we're supposed to call write text. Like just on its own, how would you call write text? Maybe there was an example in the later call packages. Here, write shell script. I see. So look at this. This was a very simple one. So this should work like this, right? We pass in a write text. And then we need a default.nix that is like something like this. I don't have a default.nix here, right? Yeah. All right. So here we go. Call package hello nix. We don't care about any of this. We're not overloading anything. And then call package hello nix. So, oh, but it's not hello nix. It's test1.nix. Okay, so I think that works. And then here, whoops, test1.nix is gonna take write text and call package is gonna fill that out. So let's see if that works. I saved everything, right? Yep. Nix build. I don't think I have to pass anything. There we go. So it did make a hello text. Hey, look at that. Here is some text. All right, so we do, I guess that's how it works. I'm kind of wondering why we can't actually just use it in here, but it's probably some permissions thing, like call package set stuff up so that it can do it, but it's magic to me. Use something that imports the Nix packages. Sorry, I don't understand, Pico. Was that for something? Holy crap, this is like taking longer than my Nix solutions for Advent of Code. This is so slow. I feel like I'm building like a whole operating system. This is like building Linux. It's crazy. I got it right. Cool. I just don't know why we have to go through call packages. So where was I? I wanted to make sure I understood. Oops, I've gone too far. I wanted to make sure I understood. Where were we? Here. Wanted to make sure I understood this file that we wrote. So this we understand now, right? This will write this file and return the path probably to that file here, because that's what we saw when we ran our code. And then we have cross-compiler for host packages. So it's taking a parameter, and you can see here that when we call it, it's calling our cross-compiler for function, and it's passing the package we want it to run on. That's why it's the host package. All of these names come from up here, right? And cross packages is part of Nix packages. It's under Nix packages. So you find the one in there. We pass in as a parameter the host platform, and then the host platform will have commands like run command cc and a standard env, which means, let me start a Nix REPL again. There was that like neat little cheat sheet here. Nix REPL. This will automatically load in Nix packages. which means we should have available to us whatever it's called, cross packages cross packages cross.raspberry Pi, right? And then here we have run command cc. So there's quite a bit of things here available. I see. So these are basically all the packages that are available for this platform. So you can see, like, I'm guessing it has like Helix, for example, the editor I'm using. Yeah, there it goes. So I can run my editor. So this is just packages, but for this other platform. And so run command cc is just one of those things. It's a function. And that function takes something. I wonder if we can find out what this is. Is similar but uses the default run command cc. I think it's still loading. There we go. Run command cc is similar, but uses the default compiler environment. Okay. Run command returns a derivation built using the special commands in the standard environment no cc. I see. So you have the environment like without the C compiler, and then you have the one with the C compiler environment. Yeah, I'm running and compiling on the same machine. Last time I built the Linux kernel for my old machine, it took around 20 minutes. Well, maybe these guys should have like gave a little warning that said like, you know, this might take a while. But you know, I'm making good use of my time. I'm trying to figure out to make sure I understand what's going on here. All right, so what was it that it takes as a string? String attribute set string. The derivation's name, parameters to the derivation, and the build command. So here's the derivation name, parameters to the derivation, and here's the build command. So it's going to run this in this basic C compiler environment. So it's kind of like running it in a shell. And that's why it probably defines cc as an environment variable. Let's see, does it say that? We don't really know. I guess it doesn't say like what environment, what a basic C environment means, but okay. We'll assume that cc is always available in cc and out are probably defined in all environments. All right, so I understand this file now. So then it calls the Raspberry Pi one. We get the cross compiler for the Raspberry Pi. It gets passed in here as Raspberry Pi, and there it can access the run command cc, and then it can basically run this. Oh, but where's the emulator part? Here it is. This I don't know. Host platform emulator. So that means that Where are we getting host packages? Run. Okay. Standard environment, host platform, emulator. Host packages, build packages. So build packages is the reference to, it's like a back reference to the packages from the build system, right? So if I do packages dot, sorry, packages cross dot raspberry pi dot build packages. Now I'm back to my build machine. This is me now. And I guess I have stuff in here, right? Like whatever it is. Like my Helix thing. Yeah. Cool. So I can always get back to my build packages from the host system. But then this emulator is interesting. So the emulator is being passed in our build system so it knows like what system to make an emulator for, because it knows its host platform, right? Let's see if we can figure out what emulator is. We don't have emulator. I don't know what these are. Spawning emulator instances. Interesting. It might be quite convenient to automatically generate scripts that spawn emulator instances. An emulator spawn script by invoking emulator app. I don't think this is what we're doing. Yeah, I don't know what host platform emulator is. So this would be packages cross dot raspberry pi dot standard environment dot host platform dot emulator. Yeah, so what is that function? What is that emulator function? I wonder, maybe it's under Noogle? Nope. Yeah, I feel like I don't really get all of this. This I don't get. But it's cool, like, I mean, I get the idea is that it's going to run an emulator for this host, the target platform, right? Um, given this my build machine platform. So that's pretty cool, and I guess that works in general for everything. Well, let's keep going then, because I think we get this. This will just keep running. We're almost at the end. All right, developer environment with a cross compiler. In the tutorial for declarative reproducible environments, I remember doing that, we looked at how Nix helps us provide tooling and system libraries for our project. It's also possible to provide an environment with a compiler configured for cross-compilation to static binaries using muzzle. uh, Given we have a shell.nix, this is feeling like math now. Given we have a shell.nix. So here's a shell.nix. Here we are getting the cross-compiled platform for ARM. Call package is needed due to pull. Oh, great. Great. Let's see the argument going on here. I think it's linking now, so it might be really slow. Oh yeah, isn't it linking? Stripping. I don't know what it's doing, but it feels like it's linking because I see a whole bunch of .os. Darwin, fix Darwin cross infinite recursion. Oh my god. I don't know how. Call package is needed due to infinite recursion. Okay. Packages dot packages static. I have no idea what packages static is. I'm guessing those are statically compiled stuff. Call package. And what's it being passed here? A function. This is a function that takes in an attribute set with. Oh shit! Guys, this is how you avoid doing what I did. You see how before I had this Nick shell, right? And then I had to make call packages and like give it a file. And then in that file, oh look, it's finished. This thing finished. But anyway, I had to give it a file, test.1, and inside of test.1 is just this function, right? But what these guys have done is they just put the function inside of the call. So which means, if I understand correctly, I should be able to just take all of this and put this inside of here. So let's see. We put our function in here, right? This closes our function, call package. Make shell blah blah blah, then it closes. And then it gets passed in empty. Now why does this guy have an extra curly brace? What's going on here? That's closing this attribute set from attribute set in make shell. So we don't, let's see if this works. In call package, let's make that a little bit more evident. We can probably put this all together. Write text, make shell, close. I think this looks legitimate. And then I should be able to just build this. Let's see if that works. expecting semi. Okay, yeah. In ah, this has to close because this one closes this one, right? No? Yeah. And write text. I don't know if write text call package needs, I think call package needs this. Yeah, it still maybe needs this. There we go. And then here is my file. There we go. Here is some text. All right, this is really cool. This shorthand is really nice. I will yeah, it's really ugly, but I'm going to save this in our gist cheat sheet. Let's make another little tip here. Maybe it's not a tip. Making a library, common headers, Nix packages. Let's just put it in the beginning. We can reorder stuff later, right? So it's like call package in one file. There we go. Call package in one file. That's pretty cool. All right. So here we go. It created these two, Linux and Ming. This must be the Raspberry one, right? Why permission denied? No such file. I don't understand. Well, let's go back. Not Rust. We're not doing Rust. Go back. All right. So what were we doing? We were nix build cross-compile.nix. That was this part here, which now if I do this again, it should be very fast because it's run it already. There we go. And these are the two outputs. And let's see. So cat interesting. So how should I understand this? Is this the emulator? Let's see. Cat out. This is the output directory. Oh, we've already run it. Run the compiled program using user emulation. I see. So we've already run it, and then we outputted it to the file. So shouldn't I be able to cat this file myself? Like, I don't understand why it's not working. Oh, did I just type it in wrong? All right, well, what was I doing that was brain dead? I don't know what I was doing. Maybe I was just brain dead. But so yeah, it ran the emulator. For hello, this program we compiled, and then it did the output. It redirected output to this file out, which is the result basically of this derivation. And so both of them worked. Wow, that's crazy. So I'm guessing now, if I change this file, what was the file called? Cross-compile? Like new test, then my understanding is this won't have to recompile everything, right? This will just, because we already have all the C compiler environment now that we've had to set up for Raspberry and for ARM. So now we should just be able to do nix build again, and it should be much faster. I don't know what all those failed things are, but I'm guessing. But look, it says hello world new test. And now hello world new test. And this should be a different directory because we've changed things. GNUABIF. And last time we did this, it was oh, is it the same thing? It shouldn't be. Let's try this again. Yeah, that's still the old hello world, and this is the new hello world. So I guess the store hash here is different, even they're both the ARM ones. All right, I think we've figured out how this works. I think this emulator stuff is really cool. Does that make sense? Interesting. Where is the cross-compiled binary? It's probably building DRV. These derivations will be built. So I think this is a directory. Oh, it's not a directory? That is not a directory. But derivation. So maybe this is basically the equivalent of the executable that goes in here. You know, where we would be able to tell is basically we are running this hello world, right? So hello. This is the output hello. Cat out. Do you think we can just like do you think that'll work? I saw it briefly. Where did it say it? Here I am, /build. Maybe it's temporary then, right? No, that doesn't make sense. Maybe it's like just relative to itself. Because I don't think we have a /build. It's probably it's probably like ephemeral to this build process. And then once it's gone, it's gone. Because it's not part, the derivation that it's really building here is stuff that's an out. So, doesn't that mean I should be able to like put the binary into out? Right? Let's do that. This should happen first. We first make the directory, and then we're going to put hello into out.hello. And then we'll also copy hello to out. Yeah, this is too much. This will be our text file, so this will be the output, and then we'll copy the executable here. And let's see what that looks like. Cannot stat hello. Why? Make directory out. That should be fine, right? It just doesn't like this. I don't understand why it can't copy it. -o hello. It's compiled it. But then why can't we copy it? Like maybe I can get a better understanding here. Maybe like maybe I'm copying it wrong. We did this when we were like trying to package existing software, but it didn't have like some of the install phase, if you remember. So then we did like a copy inside of here. Copy. No, that cannot stat hello full logs. Let's look at this. Cannot stat hello. It doesn't tell us anything. So does that mean we didn't create anything here? Yeah, I guess not. I guess I can't make a directory like this. It's probably not allowed. But I wonder if I can, I probably can't do this either, right? Yeah, I guess that won't work. Failed. Oh well. I think to answer your question, I think it is ephemeral, and we can't access it. There might be like some command in Nix packages like copy file or something that does have access to it. All right, what did I screw up here? Emulator runs out and then we have to like print it, right? I think that will get us back to a working system. Yep. All right, sorry for that detour. So where are we? Oh yeah, we were doing this, which is a really cool way to basically not have an extra file. We have a function where we want all of these things that come from Nix packages, but instead of getting it from Nix packages, the top level, we're getting it from this cross-platform. So now we're getting make shell, zlib, package config, and file from it. And then we make a shell. So make shell is going to be a shell for the target platform. Does that mean we're going to get a shell on another platform? What? That's incredible. Wait. So let's make this. What do I have? All right. So here we go. We have we are grabbing the release 2311. We're getting it for Arch. We're getting packages for Arch. Then we call package and we're passing in all this stuff. Native build inputs, build inputs. I don't know what these do. Let's see. These tools run on the build platform but are configured to target the host platform. Native build inputs. File. Build inputs zlib. All right. And then they want a hello.c. Did we already make one of those? No, we haven't. Oh, let's just copy this. I don't really need to practice writing C code. Okay. And then we do Nix shell run file hello shell.nix. Ah, it's gonna like tell us file is the file utility that tells us more about a file. Oh, I didn't do this yet. Oops. That's not going to be good, but it has to first, I guess it doesn't hurt to do it backwards. It's just going to fail because there won't be a hello dot, there won't be a hello executable file. So file is going to say, I don't know what you're talking about. I keep mucking with trying to get chat working. And sometimes it does and sometimes it doesn't. I just can't figure it out. So weird. Oh my god, is it rebuilding stuff? Are we picking a different platform we're running it on? Hold on. What platform are we running it on? This one. Arch multi-platform. Didn't we do this already? Oh, we didn't. No, 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 no. We're not going to start a new one. Let's just use one that we've already used, huh? Like Raspberry Pi. Raspberry Pi, right? This at least won't have to recompile everything. Let's make sure we're using the right release. Release 2311, 2311. So yeah, it should have all that already. Let's try this instead. Thank God, right? No? I hope it's not running everything again. Maybe it has to compile some of these tools. So cross-compiling isn't for the faint of heart, it seems like, because this can take a long time. Unbelievable. But the idea is that we're creating a shell that is on our, that's targeting our cross-platform, and then we can run stuff on it like compile or compile to create that, and then file to actually test what it is, which is pretty cool. Oh, look at this. A detailed explanation how of cross-compilation is of how, it should be of how, a detailed explanation of how cross-compilation is implemented in Nix can help fix those issues. I see, it's in the reference manual. Cross-compilation. This might be a good thing to read at some point because I felt like we got the light version of what's really going on. Let's see. Do we want to let this keep running or not? I think we get the idea. What I'm kind of curious about is instead of passing in run, do you think we can just like Nix shell and then we can just like be in a cross-platform shell? Does that seem like magic to you? It sounds kind of crazy, doesn't it? It feels crazy. So much here. Well, this was good. I think what I came out of this is first that there's this really neat way to like use call package um, here. That's super cool. And another thing is cross-compilation is possible using Nix, which makes it easier because you can kind of just, I think the thing to take out of this is that Nix defines a whole bunch of cross-compilation target platforms. And if the thing you want to cross-compile to is here, then you're all set. If you want to know what your platform is, there's a program called config guest that you can get. And you just run this, just copy this command here, and it'll tell you what platform you are on. And as we tried before, mine is x86 64 PC Linux GNU. So this is the CPU. This is the vendor. I guess this was the OS. And this is the ABI, which is like compatibility for calling binaries. And I think it was the vendor and ABI are often omitted and out. So the important thing here is x86-64 Linux. What's interesting is we see x86-64, but like, where's Linux? Platform config string. So to get the platform config string, you actually call this. And that's what I think you would actually R64. So if you have Arch64 multi-platform, which was this one here, its actual config string would be Arch64 unknown Linux GNU. And then when we're actually trying to call, we don't say Arch64, multi-platform, we actually pass in the real config. So even though there are names here, you don't use these. You would use like the name that comes from its config. But we did use Raspberry Pi, so let's see what this one was. REPL. Oops, that's not what I wanted to do. I wanted to run, what's it called? Packages cross Raspberry Pi standard environment dot host platform dot config. Oh, so weird. ARM 6 da la la la. So does this mean I could use this? Cross-platform build platform. I see. So if we needed to pass a config, we use the config here. But when we're able to dereference the cross package, then we don't, because you see, for example, here we're just dereferencing it, so we don't need to get this unknown Linux GNU thing. But if we were using it as a config option in build, then we need to find it. Does that make sense? I didn't really get that nuance when I was first reading it the first time. Well, I guess that kind of covers it. I'm still waiting for this thing to build, but I don't think there's much else to do here. What you guys think of cross compilation? Did it make sense? I feel like I half get it. I'm not really sure what I even don't get, but I think I like 3/4 get it now. So I think that's good, because if I have to do it next time, I'll know to come here, and I can probably like, what's the word? Find my way through. Waddle, waggle, muddle. Maybe it's muddle my way through. All right. What's up now? Is it getting late? Where is my girlfriend? Is she coming home? Will she ever be home? Am I alone forever now? Do I want to be alone? Ever? Forever? What I really want to get to is okay, so we'll consider, should we consider this part done? Should we kind of wait for it? Anyway, I'll just keep talking. What I would really like to get to is the part where we actually get to NixOS, because I want to know like how to use NixOS. I don't know how much there is to know, but I guess I kind of want to know how to configure it, because I've been like running. You see, I'm running on NixOS here, but I don't even know how to use NixOS. I know there's like a, is it like, is it under etc. config? No, Nix. I have configuration Nix. Is this it? I think so. Um, and I don't know like exactly how this works. I put this in here. Um, but you know, it's like I don't really know how any of this stuff works, and how do I then like further config these these utilities, you know? Like, hey, I want whatever options by default for Erlang, or for, can I have Git automatically start with, I don't know, config variables. So I don't know anything about that, and it's kind of funny because I've been like learning Nix for a while now, and I don't know anything about Flakes. I don't know much about NixOS. So maybe we'll eventually get there. What is all this? What are all these guides? Oh boy. At least language stuff we kind of get, you know? At least the language stuff we kind of understand. Wait, what happened? Is it still compiling? Ah, yeah, it's still compiling. Keep compiling, go. But yeah, this is cool. And then I would love to learn how to make a Docker image from Nix. That sounds so cool. Like, I wonder how hard that is. Module system. That probably will be pretty easy, I guess. So we're at cross-compilation. We're going to do module system sometime. It looks like there's 2 parts. We'll be done with that, and then we'll go NixOS, and then we're kind of done. I feel like after NixOS, guides like these are just random stuff. So that'll be good, right? and then we'll play around with NixOS just a little bit. Maybe I'll even like install. Is it possible? Well, I don't know. I don't know. I was thinking like it'd be kind of cool to set up Nix on a brand new machine. Maybe I'll use like the Elgato thing and like show how I install it and everything. Wade? What do you mean, Wade? Where did you see Wade, Pico? I didn't catch that. I kind of want to see this shell thing. I'm kind of excited to see like, hey, if I have a shell, does that mean I have like I can just run the shell and be in another emulated, like not emulated, like I guess like environment? I don't understand. So I guess I don't quite understand how that all works. But that's okay. Wade, you're right. Wade, I can wade my way through it. No, isn't it? Wade? Maybe. I am terrible with what are they called? Expressions, metaphors, idioms. And one would think I'm just not very good at English. No, I'm just really bad at idioms. It's just like I always say it backwards. I think it's like the tism. So there's that. Huh. I guess while I'm waiting, what are you guys up to? Are you guys gonna get off now? I'm wondering if I should do something else after this. I really enjoyed Gleam a lot. I kind of want to play around with Gleam more, but maybe it's better to finish. Like, I kind of feel. Oh, look, we're echoing timestamps. This feels like we're getting close to the end. Is the stream getting like, when it compiles, does the stream get messed up? Because it's like I'm multi streaming, I'm compiling like whatever, an operating system. um, oh, it seems okay. Cool, cool. Yeah, I kind of feel like I should really focus on finishing some of these, like that I've started instead of like starting new things. So, like, I want to finish Nix, and I think we're pretty far along in assembly language for Atari, so I kind of want to finish that also. But it's funny, I bet like most people who are into Nix don't find assembly language very interesting, right? Like you guys are more on the Nix people, right? Like you don't care about assembly language on Atari 8-bit machines. Is that right, or am I just making when I tried to follow along? What do you mean, Pika? What do you mean you tried to follow along? What didn't work? So, didn't we find a bug the in this text somewhere? I'm kind of tempted to try to fix it. If maybe I thought there was a bug. Oh, I think the problem was here that I just felt like this confused me. You've done a lot. You overloaded your system. What do you mean? Like what happened? And Findus, that's great. I think I knew that. But okay, so Findus, you do you use Nix also and you've done a lot of 6502 programming? Like both of them? Yeah, I don't like this because I just got confused and now I'm looking at it, I feel really stupid for having been confused there, you know? Um, I guess I feel like they've changed how they did it. Let's see here. So, let's see how they do it here. Nix build. Yeah, I guess they always did it this way, so I was just being stupid. So I don't think there's anything to actually fix. Laptop can't handle a build and listening to the stream. Oh, sorry, Pico. Ah, and Findus. Oh, so you'd be fine with the 6502 stuff, or maybe you'd be bored with it because you already know 6502 stuff. God, when is this thing gonna be done? Do you think I need like a new computer? It's not. It's sort of like not making use. I bet it's not parallel compiling, right? On threads. So probably it's just that my cores are slow. My cores are slow. La 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 la. Well, since we're waiting, right? Um, I wonder how you learn Prolog. The specs of my machine, I have no idea. There must be. I'm running Windows, so it's like I don't know Windows that well. Let's see. Do you like type? This PC, and I do like maybe about or something. Yikes. Okay, now my computer's like really slowing down. I mean, we were in a Prolog directory, right? So maybe we should see what Prolog's about. So I have a Ryzen 7, AMD Ryzen 7 3700X 8-core processor, 3.6 gigahertz. It's probably pretty old. I wonder what's the best way to learn Prolog online. Best way to learn Prolog. Programming Prolog. Art of Prolog. I think the Art of Prolog I've heard about before. And I think it's like, oh, this is Amazon. I think it's like no one's copywriting it anymore. Like because it's no longer in print, so you can just kind of like use it. Hey, look, we're done. Hello cannot open hello. Yeah, that's because, remember, we didn't run it in order. Hey, we're finally back. Let's go back to this real quick. And, here we go. We needed to first compile hello .c. So remember, because it's been so long, we have a, we created a hello.c file, right? And now we're going to compile it. My native platform here is a x86 64-bit running Linux, but we're trying to cross-compile to Raspberry Pi. So in our default.nix, no, that wasn't default.nix, shell.nix. We defined it to be Raspberry Pi, and we make a shell under Raspberry Pi. So you see, we make shell. We call make shell here, and that's when we can run this shell, and we pass in shell.nix as the file name. And now we're going to run hello cc hello.c -o hello. Hopefully this doesn't like take nearly as long as the last one. Look, it did it directly, right? So now we have a hello, but I shouldn't be able to run it. because I'm not running Raspberry Pi. But I should be able to run it when, well, I should be able to run file on it and know that it is a Raspberry Pi file or whatever. ELF32 LSB ARM blah 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 blah. So that's cool. I don't think I can actually run that file though. Right? Yeah, I can't run it. So nix shell shell.nix. So in here I can run stuff like you can see that in this environment my C compiler is not the same, because if I exit the shell, right, where I entered the shell with that, now if I do echo cc, I'm back to my normal C compiler. Whereas when I entered this shell, it changed my C compiler to be the one for my target platform. So I guess like what happens with this shell is it's basically a shell that will let me do cross-compilation. But yeah, that's the important part. The native build inputs is package config and file, which means that the file command is in its native format. So that's why I'm able to run file. If I change that, I probably can't run file. So if I got rid of this file here, then probably this thing won't work. Where? Here, right? Where we're running the file. And, oh, it did work? These tools run on the build platform but are configured to target the host platform. Alright, I don't really know what that means. So that stuff I don't get, but the rest of it made sense. Yeah, with the emulator again, that was interesting, wasn't it? The emulator host packages, hello. Do you think we can actually like run it though? Yeah, I don't want to get lost in that, I guess. We could try to write it, but it's just, yeah. Let's do that next time. But I think you're right. All right, do we want to do this? All right, because I don't really get the emulator, but I think we can. So let's try this. Do you think we can run this in REPL? So what we can do here is host packages. So we're basically running Raspberry Pi standard environment as host platform emulator, right? So let's see if we can do that here. import, and then how do we like make it easier to access that? Here we go, import. We put parentheses around this. Packages cross Raspberry Pi, right? And then we do, and then in here we want to pass in I think we want to pass in standard environment, right? And now in here we can call, let's move this back a little bit. This is really off. Standard environment. And then in standard environment we call standard environment dot host platform dot emulator host packages. Wait. We don't have host packages. This is the Raspberry Pi stuff. Build packages. How do I pass in the host packages? Maybe we have to do it this way, where we pass in cross packages cross. I think this should work if I understand this correctly. And then so we do packages cross dot Raspberry Pi dot standard environment blah 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 blah. Because this call package should be able to basically grab anything from packages and pass it as a parameter. So that was one, and the other one was build packages. Which is the same thing. Packages cross dot Raspberry Pi. Actually, since it's host packages, it should just be our normal package, right? Let's just do it anyway. Raspberry Pi dot build packages. So it looks like I am Pico. We'll figure it out next time, right? On the REPL it evaluates 2. But then I don't know how to pass in hello. I think that's where we have to do local files, which is a pain in the ass. So we don't have the hello, right? So we need to create, I see. So maybe we needed to create the hello also. So I'm guessing if I run this, yeah, it doesn't know what hello is because obviously it can't access that. Attempt to call something which is not a function but a string in context. Which one? Packages cross raspberry pi. Emulator. I guess I don't know how emulator works. But remember we did local files before, and that was like somehow a bit of a pain. Yeah, we had to use file sets or something like that. Ah, can I do that? Can I just use a path? It didn't like. Is the problem that you aren't building hello into default in that? Maybe. Ah, from the shell. What, the emulator command? It doesn't have access to this, does it? Is the emulator just a program? I don't really know, like, even what standard environment is. Oops, I got rid of it. Sorry. The REPL can build the emulator and then you just run it directly. The REPL can build the emulator. So in the REPL, let's say I run REPL. This Oh, because it has Nix packages. So you would run. All right, so here is build package, and then you have to pass it the string. Sorry, what? It needs to be. Oh, you wanted to add the whole thing as a string for string interpolation. but the emulator needs the executable, right? Doesn't it need this? I think the emulator is run more like this because does that exist in your system? You mean does when I ran it as a string, does what's this? Is that what you're asking? Ah, you're saying this is something? No. Oh, user program. Ha! I get it. I see what you mean. So you're basically saying, um, that's the path to the emulator because when we ran this string, this is a function that takes this as a parameter. Is that the idea? So it's basically saying, give me the emulator for this for my native platform to this build platform. That's how the emulator works, and this returns you the executable emulator. That's what it's doing. So yeah, you don't need the strings, right? Like we could just run it like this and it returned it because this is the function, so it's taking in this function and and this is its parameter. So I mean, like, you could change this to anything, like I want to run the Raspberry Pi emulator, but from oops. I mean, maybe some of these are not defined, right? Packages cross Arch 64 Android. Like maybe some of these don't exist. So here's like a different emulator, and this one I'm guessing I cannot run because it's for the ARM thing. Oops, what happened? Well, whatever. Like I didn't expect that it would work, but yeah, that makes sense. Cool. Thanks for explaining. I guess like my problem was that I didn't really understand the syntax of what was going on here. Oh, they put it in this dollar sign because it's a shell script. But I'm guessing that this is this actually a function or is this like an actual executable? Right? La, 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 la. So this, when it says lambda, that means it's a function, right? So I think it's a function. So this is a function. It's not an executable. and it takes this as a parameter. Yeah. All right, great. That makes perfect sense then. Um, got it. It's just that we're inside of these multi-line string, but we're still doing string interpolation. So in the string interpolation, this is just replacing a variable, but here it's actually calling a function and giving it a parameter. All right, now I know how to parse it. It makes a lot more sense. Thank you, Pico. That really helped a lot. That was super useful. I think everyone else finds that very useful too. Now I feel like we're like from 60-70% understanding to like 80, so much better. Well, we will call it a day here then. I will not do prologue because yeah, that was quite a bit of time. We've been at this for 2.5 hours, so not bad, everyone. If you've stuck around, thanks all, and you guys are really great. Thank you for being joining me for this. And if you're seeing the VOD of this, then do like and subscribe. And we'll be doing more Nix soon, where we are actually doing modules and Nix OS. That'll be fun. Feel free to join the Discord server also if anything was confusing or you just want to chat with us. Talk to you later. Take care. Hopefully, see you tomorrow sometime soon. Thank you all. Bye. All right. See you.